Hello, CAD 244. I hope you guys are all doing well. It is already time to start talking about our final project, which is pretty exciting. It's a little crazy that the semester is almost over. So the final date for this class is March 10th. So, a little less than 2 weeks away. And so, yeah, let's get going on our final. So this final is based off this book called 507 Mechanical Movements. So this is kind of an old school book of some pretty basic mechanisms with gears and ropes and pulleys and levers and stuff like that. But really important, really cool use of leverage and all kinds of mechanical stuff. I will be providing you the PDF. So the PDF looks like this. And if you scroll down, you'll start to see the movements. So they're all numbered. And then below the number, there's a little explanation of how each one works. And so what I'm going to have you guys do is you're going to kind of scroll through and see which one of these movements you feel like you could successfully model. I think most of them will be challenging. It'll challenge you pretty good. But here is how they might look. So here's a progression, and I have two examples. So this is movement number 31 in the book, and this is someone's SolidWorks model of that movement on a little stand. So that's going to be part of the project too, is to produce this as if it's going to be, cut on the laser cutter or different parts produced on the 3D printer. So obviously the stand and some of the other axles and things were produced with the laser cutter, and then the white parts are 3D printed parts. And then here's the final model that's operable. You can turn this crank, and the worm gear is going to go ahead and drive the regular tube gear. So here's another example, 120 in the book, produced with kind of slight variation on this design. And if you found one that you needed to modify a little bit, we could talk about that as well. But here's the inventor model, and then here's the actual produced desktop model for that. So what you're going to deliver is an assembly. Obviously, in that assembly is going to include parts. So the assembly is going to move as intended, and it has the proper mates and constraints in there. So there's going to be some things. And the drawing set. Individual parts, individual part drawings for each individual part, and then an assembly drawing and an exploded view of that assembly. To produce some of these, you may have to learn some new skills. So, for example, this one, if you were to produce that one, you would want to research how to produce gears, how to model some gears. And there's different ways of doing that, and there's different ways of researching that. So you could potentially go to Solid Professor and go to some of the advanced tutorials for Inventor, in how to use Inventor to draw gears. Or if you didn't find what you needed there, you may go over to YouTube. You may find different resources on YouTube. But this is a really common thing to have to do. If you become an intern or you go out and get a job, you are immediately going to start learning all kinds of new stuff and having to figure out new stuff on your own too. So, for example, when I took my internship, I had to figure out how to draw a helical pattern for a spiral staircase, and then unroll that pattern so that it could be cut on a water jet cutter and then rolled back up again into the helix out of sheet metal. So so you may choose a movement where you may have to figure out how to like mate a belt into an assembly, or a chain or a geared assembly, something like that. So there will be an element of some research and some new learning to kind of figure out how to put this together. So yeah, that's kind of the nuts and bolts of our final project. Obviously, we are designing these as if we would be cutting them on the laser cutter or 3D printing them. Unfortunately, we're not in person, so they'll have to remain designs for now, digital designs. But I would like you to keep in mind, or design these rather, as if you were going to make them, as if at some point down the road, we would use your files to produce them on the laser cutter and on the 3D printer. So, you can visit D2L and check out the PDF and upload that PDF. And let me know if I can help, or if you need help selecting, or anything else. So yeah, should be fun.